All right, let's take a look at a smart cylinder. Now, smart cylinder is a cylinder that will tell the ECM what position it's in. So normally a hydraulic cylinder would either get oil sent in on the major end, the major surface area or the large surface area here, and push the cylinder out, or it would go on the annular surface area here where the rod is and it would retract. That would be very normal. But the only thing that would really say whether the cylinder has moved would be the operator's eyes watching it move. And if the operator said move more, it would simply send more oil and the cylinder would move more. But smart cylinders now use an ECM control so that the operator, either through a GPS integration like a TopCon or an AccuGrade, or even through programmable settings inside the machine, they're able to hit a button and use a one-button solution where the cylinder will go into a predetermined position. In order for that to happen, the cylinder needs to be part of a closed loop. So the cylinder opens up the control valve sends the oil, the piston moves, the rod extends, but we need a feedback. Now, that's where this little rod comes in right here. This little rod is connected to the cylinder itself, and it actually goes through the rod of this cylinder. This rod is hollow. And so there is two little finger contacts that make contact with a resistor strip right here. If I zoom in, we'll be able to see that. So those two light gray strips you're seeing in the picture there, those are the resistors. And so what's actually happening is the little two fingers that are in this piston make contact and actually jump across the two resistors, setting a resistance. As the piston moves out, the resistance changes, and as the piston moves back in, it also changes. And the ECM would have been calibrated with this cylinder to know what the resistance is retracted and to know what the resistance is fully extended. And now anywhere in that sweep, it'll be able to know what percentage of cylinder movement has actually happened. So we can actually see if I push this rod in, that sensor rod goes right inside of it. And so again, I can pull it out just like that. Now normally the electrical connectors are right here, and so we can see this little 3-pin connector that gets sent to the ECM. So the ECM signal comes in and it's got a 3-wire, so that means it's got a reference voltage, a ground, and a signal return. Now we've opened up the other side to see what's actually going on in here, and it's quite a simple connector. One of these connectors go to our 3-pin. The other one of these connectors are actually going to the sensor rod itself. And so one of the reasons why these cylinders seem to fail is that the high pressure hydraulic oil in here that operates the cylinder is getting through the sensor, and the sensor is not sealing enough, and it's actually pushing the hydraulic oil pressure inside this cavity. And what happens is this connector is not hydraulic high pressure sealed, so it starts to leak, and the customer complaint is that the cylinder is leaking from this connector. Now the only reason that's happening is because this sensor rod is leaking, and that's causing this pressurized cavity. Remember that pressure will act equal and undiminished within a confined space, so whatever pressure is here will eventually get into this cavity here, and eventually, let's say there's 2,000 psi, eventually that 2,000 psi is going to try and push through this electrical connector, and it's not designed for that, and so we'll see an external hydraulic leak. So while this looks like it's serviceable, the manufacturer of this cylinder does not allow a technician to service this electrical connector, or does not allow them access into here, does not sell them the part to replace this sensor rod. Instead, this cylinder is replaced as a whole.